Okay, so here's some examples of converse and contrapositive. We're going to be rating them in words and deciding if they're true or false. So let's start with our statements here. We have P, -1 squared is equal to 1 squared, and Q, 4 squared is equal to 16. So first, A says to write the implication if P then Q in words. So we're just going to insert the statements here into our kind of if-then and write that in words. So if -1 squared is equal to 1 squared, then 4 squared is equal to 16. So now to answer if this is true or false, we need to think about whether the hypothesis and the conclusion, respectively, are true and false. So 4 squared is equal to 16. That is, of course, true. You might remember for the hypothesis that we exponentiate or do the exponent before the negative. So this one is actually false because on the left-hand side, we would first square the 1 and then apply the negative. So the left-hand side is equal to -1. The right-hand side, 1 squared, is of course equal to +1. So that's false. So you can think of this in two ways. First, for an implication, if the hypothesis is false, we automatically say, that the implication overall is true. So that would be, I guess, the third row in the truth table if you want to think about it that way. So next, to write the contrapositive, which is if Q then P. Basically what we're going to do is switch the hypothesis and the conclusion here. So if we would say if 4 squared is equal to 16, then -1 squared is equal to 1 squared. All right, so now to determine if that is true or false, again, we know that this part is true, which is now our hypothesis, and this part is, as we said before, false. And remember, that's kind of the one case where an implication is false, when the hypothesis is true and the conclusion is false. So notice already that even though the implication, if P then Q, was true, the converse in this case, if Q then P, is actually false. So moving on now to do the contrapositive, which is, remember, this is our negation symbol there in front of the Q. So reading this out loud, we would say if not Q, then not P. So for us to negate a statement, which is what that means with the not, we could just insert the word not into it. But since our statements here are mathematical equations, we can kind of negate them by simply changing the equal sign to a not equal sign. So we'd say if 4 squared does not equal 16, so that's our not Q, then -1 squared does not equal 1 squared. All right, so we want to know if this now is true or false. So this is our hypothesis, which is now false, right? 4 squared is equal to 16. And then this part is actually now true. But that last part didn't really matter because if our hypothesis is false, we can automatically say that the implication is true. So notice here that our implication and its contrapositive have the same truth value, and that's true always.